Hello class, this is lecture 19 for Econ 4001.02 and I'm your professor, John Raybeck. So this lecture we're going to cover just, some stuff about the types of production functions we'll use for the cost minimization and profit maximization problems. For profit maximization, we'll actually need some more structure on the production functions. So we'll be using different variants of the production functions that we go over here, but they're going to have the same flavor. So we're going to consider different types of production functions, and these again are just given by f of x, right? So a function from inputs into output. And here units are important, so just again, we cannot take monotonic transforms of production, right? If I take a monotonic transform that scales production down, this actually means I can produce less, so that I'll make less profit. So we can't make these transformations anymore. The production functions will have natural analogs to utility functions though, right? So just like an indifference curve was important for utility functions, some notion of a constant or the level set of production functions will also be important for studying profit maximization and cost minimization. And the first example of this is just an isoquant, right? So an isoquant is denoted I of y, and this is the natural analog to an indifference curve, right? So I of y is the set of inputs that produce exactly y, right? So this is just like an indifference curve where we were considering the amount of goods that give utility at least u bar, right? So this isoquant is going to take the role of, the indifference curve for these problems. The first production function we'll study is going to be linear production. And here, adding any unit of inputs 1 and 2 will increase production, but at different rates. So one example of this could be, producing energy via solar or wind energy, and this produces kilowatt hours of electricity at different rates. So in this case, the linear production function is just given by f of x equals a1x1 plus a2x2, and this has linear isoquants, right? So just like before we had linear indifference curves, here we're going to have linear isoquants for this function, or for this production function. The next type of production we're going to deal with is Leontief. And here we need both or two inputs at some fixed rate in order to produce an output. Here, for example, it might be producing bicycles, where you use one frame and two tires to produce one bicycle. In this case, the Leontief production function is going to be given by this production function f of x. That's the minimum of the amount of, say, frames you have and the minimum of the amount of tires you have, where a1 and a2 are coefficients that appropriately scale frames and tires in order to make bicycles. And again, this will have L-shaped isoquants where you're going to need to look for the corner in order to find, you first find the corner of the isoquant and then you just extend your line up and left in order to find the other parts of the isoquant. Another production function we'll deal with is going to be Cobb-Douglas. So this is an intermediate case between the others. Again, I don't have a good intuitive story for Cobb-Douglas production, but it's going to be practical since it is in fact differentiable, right? So, and differentiable in nice ways, right? So the Cobb-Douglas production function is going to be given by this f of x here, where there's some a coefficient that tells you how much you produce. So a is often called, this capital A here, is often thought of as like a coefficient on level of technology. Because if you increase A, then you can just increase your output, right? Regardless of what your inputs are, it's scaling it up. And then here is the normal Cobb-Douglas part, right? And it's important that these are products because we want our output to be non-negative. So here we can't look at logs of our Cobb-Douglas production function in order to get outputs. This is just going to have hyperbolic isoquants, just like before we had hyperbolic indifference curves. And again, this coefficient A is just talking about the level of technology. Great, so here we discuss some different types of production function. Again, these are nice because we'll be able to draw things related to these. They won't be so nice for solving profit maximization problems for a reason we'll discuss later. But again, we'll be able to alter these production functions in kind of relatively small ways in order to get the same ideas and same solution methods. Great, thanks for listening, and I'll see you next time.